Yes, good morning, students. So, in the previous video, we discussed about the various concepts related to the illumination engineering. Okay, we defined the term illumination and some of the definitions related to illuminations we discussed in the previous sections. Okay, so the important concepts, or you can say important terminologies, which is required for the illumination engineering, we discussed in the previous class. Right, in this class we'll discuss about the laws of illumination. Okay, there are two laws of illumination. One is a inverse square law. So first one is inverse square law, and one more is there Lambert's, that we'll discuss later. So on the first one is inverse square law, then another one is a Lambert's cosine law. Okay, so these two are the laws of illuminations here. Okay, so we'll start with the first law of illumination, that is inverse square law. So here consider the point source of the light. Okay, yes, as shown in the figure here, you can see the point source. Yes, so this is the point source. Yes, consider this is a point source. Okay, so it is placed at the distance of d1. Okay, and these a1, a2, a3 are the surfaces, plane surfaces. Okay, and these plane surfaces are placed at the distance of d1, d2 and d3 respectively. Okay, so this is a point source. The surfaces, plane surfaces are placed, a1, a2, a3 are the plane surfaces that are placed at the distance of d1, d2, d3 respectively. Okay, so that I have explained here. Okay, so here let the point source within a solid angle. There are three parallel surfaces which are a1, a2, a3 are placed at the distance of d1, d2, d3 respectively from the point source. Okay, let I will be the intensity of illumination from the source here. So so this is the point source. So point source, the parallel surfaces a1, a2, a3 are placed at the distance d1, d2, d3 respectively, and the intensity of this light is considered as I. I is the intensity of the light which is emitting from the point source here. Okay, now let the solid angle of the subtended between solid angle of this particular is given by, so solid angle is nothing but the luminous flux per radiance. Star radian is nothing but your intensity. So you know that the intensity of the light emitted is nothing but the flux divided by solid angle. Okay, so you can calculate the total luminous flux of the point source. F is equal to, so it is cross multiplication I into W, that is I is intensity of light and W is the solid angle. Okay, now the illumination on the surface, so area A now. So I have to calculate the illumination, how much is the illumination on the surface area A1. So from this point source, that I have to calculate. Okay, so illumination definitions, and with the so the formula for the illuminations from the definitions which we solved in the previous, which we discussed in the previous class. So intensity of illumination is the flux divided by area. Flux per unit area is called as a illumination on the surface. So I have to calculate the flux, okay, per unit area here. So flux is what? So you calculated the total flux emitted here, I into W. So area is A1. So here the flux is I into W. So area of this surface is A1. Okay, so that I have given here. So flux is intensity into solid angle divided by area here. Okay, and area, how to calculate area? So how solid angle is, you know the solid angle definitions from that. So solid angle is area per radius square. Okay, so area is per radius square is solid angle is equal to area divided by radius square. So therefore area of the surface is equal to solid angle into radius square. So here radius, we are taking R instead of R, we are taking D here, R1, R2, R3. So R1, R2, R3, we are taking the distance D. So here the area A1 is equal to W into R square. R square is nothing but D square, or D1 square, that is distance 1 here. So distance 1, so D1 square, I am taking it as D1 square. So the area of the surface from the point source A1 is given as W into D1 square. Now substitute this area here in this equation and simplify it. So substituting this area, I into W will be as it is. So I into W as it is. So A1 is equal to W into D1 square. So W gets cancelled, solid angle. So E is equal to I divided by D1 square will be remains. Okay. Similarly for the different surfaces, similarly for the surface area at A2. So similarly on the surface area A2, so E2, you can take it as E1, it is E2. So it is equal to I into flux divided by area square, so flux divided by, so it is flux divided by A2 means area 2, that is, so flux is I into W, so area is W into d2 square. So there d1 square, it is d2 square, so W gets cancelled, E2 is equal to I divided by d2 square. Similarly for the area A3, so I is equal to E3 is equal to I divided by d3 square. So hence what from this from this derivations what we understand, hence the area elimination E of the surface A1, A2, A3 are in the ratio of 1 by d1 square is to 1 by d2 square is to 1 by d3 square. Okay, so now, so from this I can state the elimination. Okay, elimination here, so the elimination of the surface, okay, illumination on the surface is inversely proportional to the square of the distance between the surface and the point source here. So statement of this inverse square lines, so the illumination on the plane surface is inversely proportional to the square of the distance between the surface and the point source. Okay, so provided that the distance between the surface and the source is sufficiently large, if the surface and the source, the distance between those two, if it is sufficiently large, then the intensity or illumination of the lamp is inversely proportional to the square of the distance between them. Okay, so that is called as inverse square law. Okay, so that is what inverse square law. So E is equal to 1 divided by d squares, or I divided by d square is the inverse square law. So you can state, in other words, I can state the inverse square law as, so inverse square law of illumination states that illumination, okay, here you can say from this equation I can say it, so illumination on the surface E is inversely proportional, see here it is 1 by d square, inversely proportional to the square of the distance between the point source. So here it's a point source and there's a surface, so it is the distance, so distance d1, so illumination E is, so I divided by square of the distance here. Okay, so that is the, so when the point source and the surface are at the sufficient distance, okay, that is called as inverse square law. So this is called as, this is the first law of illumination. Okay, so next is second law of illumination is a Lambert cosine law. So Lambert cosine law, so this is a Lambert's cosine law, the name of the scientist who has invented this law, so it's called as a Lambert's cosine law. So still now what we discussed, okay, it's for the parallel surfaces. Okay, so inverse square law is holds good for the parallel surfaces, whereas so all the surfaces, okay, which we are using are not parallel, some of the surfaces are inclined in nature. Okay, so for the calculation of illumination for the inclined surfaces, so the Lambert's cosine law is used here. So inverse square law, it is performed that the surface was normal, okay, to the light source flux. Okay, so but illumination for the inclined surfaces can be calculated by using the Lambert's cosine law. So here you can say this is the some inclined surface, figure A and figure B shows the inclined surfaces. Okay, they are not the parallel surfaces, inclined surfaces. In that case, what is the intensity of illumination that we have to calculate. So let us, F is the total flux falling on the surface area. So F is the, so this is the line of flux, so this is the line of flux and this is the normal plane, the angle subtended between those two is called as a solid angle here. Okay, so F is the flux, total flux falling on the surface area. So from the figure, so the angle between the normal surface to the line of flux is 0 here. So from the figure 1, so from the figure, so angle between the normal and this is 0 in the figure 1. So next, so intensity of illumination E is equal to F divided by area of ABCD. That means, so ABCD is nothing but, so this particular surface, so irregular surface or parallel inclined surfaces. So intensity is given by F divided by area of ABCD, that is a flux is lumens, area of ABCD is by meter square, so it is given as meter square here. So the from the figure B, what happens, the angle between the line of flux and the normal is theta. So in the first case the angle is 0, in the second case the angle is theta. So here in the first case so the angle is 0. Okay, and the second case, the light and the surface theta angle is theta here. So that is, so the intensity of illumination in this case, F divided by area ABCD into the angle. So here angle subtended theta, so cos of theta. So intensity of illumination is, so flux per unit area into cos theta is the for the inclined surfaces. How much inclined, how much it is inclined, based on that, so cos theta will comes. Okay, so for a plane surfaces there is direct light will be falling. So for the inclined surfaces there is a small amount of inclination is produced, or angle is produced, that is called as cos theta. So thus what we can say, it is observed that the illumination is proportional to the cosine of an angle between the normal plane and the flux here. So illumination statement is, so illumination on the inclined surfaces is directly proportional to the cosine of an angle between the normal plane and the line of flux here. So I can write the illumination E is F divided by area into cos theta. So F is the flux here, so A is the area of the surface, and cos theta is the angle subtended between the normal and the line of flux here. So F is, so flux is intensity into solid angle, so flux is the intensity into solid angle. Area A I am keeping it as it is, so cos theta will be as it is. Okay, so what is solid angle? Solid angle is once again area divided by d square, distance square. So area can be calculated as, so solid angle into d square. So from the first derivations which we understand this one. So now substitute area in the equation, this equation. So area here, keep intensity into solid angle as it is. Area is w into d square. You'll get the w get cancelled. So E is equal to I divided by d square into cos theta will be remaining. The intensity of illumination is in the inclined surfaces is I divided by d square into cos theta. Whereas so inverse square law, so the illumination is E is equal to I divided by only d square. But in this case, so for the inclined surfaces, intensity illumination is equal to I divided by d square into cos theta, because so the light is, I mean, inclined at a particular angle. So light is inclined at a particular angle, so it is called as what we can say, cosine law, as the angle which we are inclined to the normal plane and the light of flux. So we are taking a cos of an angle here. So that is why it is called as Lambert cosine law. So what we understood from these two laws, so first law is used to calculate the illumination of a normal surfaces. Okay, illumination of a light on the normal surfaces, whereas in the second law of illumination, which is used to calculate the illumination for the inclined surfaces. Understood? So first is to calculate the illumination for the normal surfaces. So the second law is to calculate the illuminations of the inclined surfaces. So these two laws are the laws of illuminations which we, so based on these two laws we have a various problems. Okay, so particular module, the problems will carry a weightage. So problems are a bit easier, but you have to understand the laws of illumination properly. So if you understand the laws of illumination properly, then the solving the problems is very much easy. So in the exams you may get the, you may be asked to deduce the expressions for the laws of illumination. Sometimes for 8 marks they may ask you for both the laws of illuminations. Okay, or sometimes they may ask you some few definitions of illumination. Along with that, any one law of illumination they may ask you for the 8 marks. Sometimes they may ask both the laws for 8 marks, sometimes one law with the definitions they may ask you for 8 marks. Okay, so that is why, so these two law, so once again I will repeat it. So inverse square law is used to calculate the illumination for the normal surfaces, whereas the Lambert's cosine law, that is second law, which is used to calculate the illuminations on the inclined surfaces. Okay, that's about the laws of illuminations. So the problems on the laws of illumination we will discuss in the next class. So before that, going to the problems of laws of illumination, some of the relations, important relations will discuss first, then problems will take up in the next session. So MSCP we discussed mean spherical candle power, it is lumen divided by area. So area is 4 pi here. Okay, luminous flux, so MSCP is nothing but lumens divided by 4 area is 4 pi, so luminous flux divided by 4 pi, F divided by 4 pi. So the efficiency of the lamp efficiency is lumens per watt, or lumens divided by powers. So number of lumens divided by wattage, or number of lumens divided by power consumed. So from this you can calculate the efficiency of the lamp here. Okay, so it is once again illumination for the inclined, this equation to calculate the illuminations of a inclined surface. So also you can calculate the illumination if the intensity of flux is not given, if the then candle power is given, so the illumination can also be calculated as, you can replace the intensity of light by candle power, both are same, so Cp divided by d square into cos theta. So that can also be done, or also you can calculate the illumination is MACP divided by d square is also the equation to calculate the illumination. Okay, so that's about this one. And utilization factor, another terminology, utilization factor is nothing but it is the total light flux radiated out by a source. Okay, it is not utilized uh, on the working plane. That means utilization factor means there is some amount of light which is emitting from the source of light, but the amount of light which is emitted from the source is not completely utilized. Okay, so the left out amount of light is called as your utilization factor here. So I can define here, it is like the total flux radiated out by the source is not utilized on the working plane. This factor is considered as utilization factor. Let us see. So this is your source of light and this is your, okay, working plane. So the light emitting from this source of light is not only falling on this particular plane, this particular surface area. Some amount of light will be falling besides your working plane. Okay, so the amount of light emitted above beside the working plane, so it is considered as, so the waste light it is. So only the amount of light which is falling on the working plane, it is considered as a utilized light here. That is the factor related to that is considered as utilization factor. Okay, so that's about the depreciation factor is also comes here once when the lamps are covered with the dust. Some of the lamps we are in the industries, if you are using, so some of the lamps are covered with the dust, smoke. Okay, and they do not radiate the same amount of flux as when they are do with the time of fitting. That means at the time of fitting means, so when you are fixing the new lamps, so the amount of light emitted will be more. So as the days are passed, so some dust or smoke will be covered the surface of the lamp. So it is most common cause in all the areas. If you take industries wherever, so the dust will be covered. So because of the presence of dust on the lamps, so the amount of energy, radiation energy emitted by the lamp, okay, will not be same as the amount of energy radiated during the fittings. That is, fittings means at the beginning. So that factor is called as the depreciation factor. Some amount of light is not radiated, so that is called as a depreciation factor. Okay, so those two factors will be considered while calculating the lamp illuminations, so in the industrial applications. Okay, so that's about some of the factors and the laws of illuminations. The problems on this we will take up in next video. Okay, if you got any doubts, you can feel free to contact. Thank you.